back. Today we're going to talk about the last section in Chapter 11, which is about constructing and interpreting binomial distributions. So we'll start, as usual, with some definitions. So we're going to start by defining something called a random variable, which we usually represent with the capital letter X. And this is a variable whose value is determined by the outcomes of a random event. And given a random variable, we can then define something called a probability distribution. So a probability distribution is a function that gives the probability of each possible value of a random value, or a random variable, excuse me. And worth noting, a property of probability distributions is the sum of all the probabilities must equal 1. So let's look at an example. Let's say we have the random event of just rolling a 6-sided die. There's 6 outcomes to this event. You could roll a 1, 2, 3, 4, 5, or 6. And each of these outcomes can happen only one way. So there's just one way to roll a 1, one way to roll a 2, one way to roll a 3, etc. Thus, we can define a random variable x to be these 5 outcomes, 1, 2, 3, 4, 5, 6, where each of these outcomes occur one way. So the probability of rolling a 1 is just 1 out of 6, 2 is 1 out of 6, 3 is 1 out of 6, 4 is 1 out of 6, 5 is 1 out of 6, and 6 is 1 out of 6. If we add up all these probabilities here, they equal 1. So this is a probability distribution. Now, this is the simplest kind of probability distribution. This is actually called a uniform distribution. And we call it that because the probabilities in our probability distribution are all the same. Let's look at something that's not quite a uniform distribution. So let's say X is the random variable that represents the sum when 2 6-sided dice are rolled. So if you remember a little ways back, we drew this out, all the outcomes. Let's do this again though. So this is just the outcomes for all the possibilities when we roll 2 6-sided die. And then we add up the sums, or we add up the rolls there. So we can have so the column or the row here, 1, 2, 3, 4, 5, 6 is from our first dice. And the column 1, 2, 3, 4, 5, 6 is from our second die. So this first box here is going to represent the sum when we roll a 1 and a 1. So the sum there is a 2. So this next box is going to be when we roll a 1 and a 2. So that sum is 3. And we can kind of continue filling this out. And I'll just write these in real quick. So what I'm going to do now is I'm going to count up how many times each one of these sums occurs. So if I look at the 2 occurs just one time. There's only one way to get a 2. It's when I roll a 1 and a 1. Now to get the 3, that can occur 2 times. There's 2 ways to get a 3. To get a 4, there's 3 ways to get a 4. And I'm just going to kind of continue filling this in. There's 4 ways to get a 5, 5 ways to get a 6, 6 ways to get a 7, 5 ways to get an 8, 4 ways to get a 9, 3 ways to get a 10, 2 ways to get an 11, and 1 way to get a 12. And if you remember, there's 36 combinations here in our table because it's a 6 by 6. So the probability of getting a 2 is 1 out of 36. To get a 3, it's 2 out of 36 because there's 2 ways to get a 3. And then we have 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36. And again, if you add it up, so this down here is our probability distribution, this down here. And if you added up all those fractions, you'd see that they do indeed add up to give us 1. So I can use this probability distribution then to compute things. So for example, if I want what is the probability of the, or what is the most likely sum, I want the sum with the highest probability. In that case, 7. Or the P of 7 is 6 out of 36, or that really just reduces down to 1/6. So if we want the probability then of at least 10, so I want the probability that x is greater than 10, greater than or equal to 10. So I want those ones, right? So I want the probability of 10 plus the probability of 11 plus the probability of 12. So 4 out of 36 plus 5 out of 36 plus, oops, my goodness, 3 out of 36. I was looking at the wrong spot. 2 out of 36 plus 1 out of 36, which gives us 6 out of 36, or just reduces down to 1/6. So once we have the probability distribution, we can answer questions really easily. Now, a special kind of probability distribution, the one that we're going to be focusing on here in this section, is called a binomial distribution. And we say the binomial distribution shows the probabilities of a binomial experiment. And a binomial experiment meets the following conditions. So there's n independent trials. Each trial has 2 possible outcomes, success or failure. And the probability of success is the same for each trial. We denote that success as P, which means the probability of failure then would be 1 minus P. So let's look at an example. It says, according to a survey, about 41% of households have a soccer ball. So that's going to be my P. Suppose you ask 6 randomly chosen households. This is my N. That's the number of trials, whether they have a soccer ball. What is the probability distribution? So my X is my number of yeses in my survey. So remember, we're asking 6 households. So I could have 7 different possible responses to that. So I could have 0 yeses, 2 yeses, 3 yeses, 4, 5, or 6 houses could have a soccer ball. Now my P of X is going to be computed using my calculator. So what I'm going to do is I'm going to press second and the vars button. This will open the distributions menu. And I'm going to scroll down this distributions menu till I find the binomial PDF. That's the one I want right there. So I'm going to press enter. So first thing it wants is the number of trials. That's N. So that's 6. The second thing it wants is the probability, which is 0.41. And the third thing it wants is the X value. So the first X I'm going to compute is when X is 0. So I'm going to press enter, and it spits that out as 0.042. And then I'm going to continue doing this when x is equal to 1, 2, 3, 4, 5, and 6. But you'll notice instead of going back through all those menus, the calculator pasted this onto my home screen. So I'm just going to use this same command string here. And I'm going to get that by pressing 2nd and enter. And just go back by and update this last value. So instead of it being 0, I'm just going to update it to be 1. So my next probability is 0.76. I'll press 2nd and enter and change that to be a 2. So that's 0.306. And 2nd and enter. Change that one to be a 3. So that's 0.283. And then I'll change it to be a 4. So that's 0.148. And we'll change that to be a 5. So that's 0.041. And then the last one, we'll change that to be a 6. So that's 0.005. Now you'll notice if I added up these rounded ones, we're not going to equal exactly 1. And the reason that would be is just because we rounded here. If you use the full decimal like we had on our calculator and you added them together, they would come out to be exactly 1. So looking at our table now, if we want the most likely outcome, it'd be this one because the probability is the highest. So 2 households have a soccer ball because the P of 2 is 0.306. And the probability that at most 2 households, so at most is less than or equal to, at most 2 households have a soccer ball. So that's going to be these ones. So I could add those together, or in the case that you didn't write out the whole probability distribution, which there's no reason you need to do that. It was just kind of me demonstrating how to use this binomial PDF function on your calculator. If instead of I wanting, so here we did the probability of x equals exactly 2. If we want less than or equal to 2, we can do this on our calculator in one set of button strokes. We don't need to add these all together. So if we do second vars and go down, and this time we're going to use Binomial Cdf. So again, we had 6 trials. The probability is still 0.41. And the x value here is 2. And we hit paste. And we do that, and we get 0.524. And you'll notice if I added up these 3 values here, these 3 probabilities, 0.042 plus 0.176, 0.306, I'm going to get approximately the same thing, right? What's the difference? These 3 numbers were rounded. This is going to be exact, but for our purposes, they're giving us the same thing. The advantage of the binomial CDF is that you don't need the entire probability distribution to get it. So if I want the probability is less than or equal to whatever, this is the binomial CDF. If I want the probability that x is equal to exactly something, this is binomial PDF. and we won't worry about what the letters CDF stands for cumulative distribution function, that it's summative. And the binomial PDF, the PDF stands for probability density function, but that's really beyond the scope of this class. But if you know how to do this and know how to use your calculator here, that should be everything you need to do to be able to do the homework assignment. So this was a quick one and the last one. So good luck and nice job this year.